In this video, I'm going to show you the absolute basics of BPMN, the first introduction to the business process modeling and notation language. With BPMN, we aim to model a business process. And one of the important things in a business process is the work that is being executed. This we model using tasks. A task represents a process step and it looks like this. So a rounded corner rectangle with the name of the process step being in it. And this represents work being done by either people or machines, but at least some work being done for a particular customer or a particular claim. Whatever process you're modeling, a task is kind of the smallest piece of work that you can do within a process model. So in order to express what needs to be done in order to handle a particular customer or particular claim, we need to connect the tasks with one another. That will show the order in which these tasks have to be executed. We can do that using so-called sequence flows. A sequence flow is a simple arrow with a filled rectangular arrowhead. This denotes the control flow of the process. So we use the sequence flow to connect tasks and other elements with one another, and then following the sequence flows, we know in which order the tasks have to be executed. We need to start the process somewhere, and we can do that using a so-called start event and an end event. So a start event indicates the start of a process. So we have a sequence flow coming out of a start event and then going through tasks and then reaching an end event. And then we can understand from the model what the order of tasks is. Not all processes, or let's say most processes, are not a straight sequence of steps. There might be alternative paths, or there might be parallelism or loops. So in order to control the control flow and to steer the control flow out of this kind of straightforward path, we can use gateways. Now, these are the basic ingredients for a process model. This is what you write down. However, in order to understand it and to be able to reason about business process models, we use a concept called tokens. So tokens are not drawn, they are not part of the process modeling language, but we use them in order to indicate where we are in the process. Let's have a look at an example. This is a BPMN model. On the left side, we have a start event. On the right side, we have two end events. And in the middle, we have sequence flows connecting the tasks. In the middle of the process is a gateway. This process model has a particular meaning, so we can interpret it. We can use it in order to communicate with other people in the organization what is to be done in this process, which steps are to be taken, and we can use this to implement systems that support it. So in a workflow management system, you would give this BPMN model to such a workflow management system, and then the workflow management system would simply assign these tasks to people. Now, what does this BPMN model actually mean? And in order to study that, we're going to play it out. Let's say that this is a purchase order handling process. Let's say that the environment tells us here is a new purchase order that needs to be handled. Then from this model, this white BPMN model, we make a kind of a copy and we run one purchase order in one of such copies. So let's do that. Here we have one process instance which is yellow. In this process instance, we're going to handle one particular purchase order. And we see now in this instance, we have a token laying in the purchase order received start event. That token was put there by the environment. So the environment has said us, please handle this purchase order. Now, We're gonna replay this process instance and then handle this yellow purchase order. First of all, the start event produces a token that was put there by the environment, but it's put on the outgoing sequence flow of that start event. And now this token is ready for check stock to consume. So what does that mean? Check stock gets a token on its incoming sequence flow and then starts executing. So once check stock is active, this means that somebody or some machine is taking the purchase order and checking, is every item in stock? The result is then stored somewhere. But this task, this check stock task, indicates that somebody does that work. That's what this box means in this model. Then, when it's done, the check stock will produce a token on its outgoing sequence flow, like this. Now we are at a gateway, and this gateway checks whether the items were in stock, so it doesn't go to the warehouse, but it knows the result of this task that we've just done and forwards the token either up if it's out of stock or down when it's in stock. Let's say that in this case the products are unfortunately out of stock. So the token is now forwarded by the XOR split gateway and ready for reject order to start. So reject order starts, and again this is a task, this indicates work. So somebody perhaps sends an email to the customer like, unfortunately we don't have your stuff, but please see these alternatives, or please contact us again in 3 weeks. So see that we abstract from what is actually happening here. We just say reject order, this is a task. We just modeled somebody does some work. But let's continue. Then once reject order is done, then it produces a token on its outgoing sequence flow. And now we are ready for this process to finish, which is when the end gateway gets a token. This indicates that this process instance is done. But this was just one purchase order. There may be more. So let's replay the scenario, but then with 2 process instances. Another purchase order comes in. Again, the environment puts a token into a copy of the process model. In this case, let's say it's green. And this process starts executing. The start event has a token and forwards that token onto the sequence flow towards check stock. Check stock starts and is being executed. Somebody is checking whether all the items are there. Once check stock is finished, a token is produced onto the outgoing sequence flow of check stock towards the XOR split gateway. Let's say that here the items are not in stock again, so the XOR split forwards the token towards reject order. Now in reject order, it can start, but let's say that this takes a bit of time and people are working on it, perhaps looking for alternatives for the customer or writing an email. In the meantime, another purchase order arrives. And the environment handles that by starting up a new copy of the process model and putting a token into the PO received start event. Now the start event forwards its token. So we see the pink, in the pink model we forward the token towards check stock. The check stock starts, and then once that finishes we are in a position to choose between whether the products were out of stock or in stock. Now let's say here the products were in stock, so the XOR split gateway forwards the token down. Now reject order is ready. So you see now the green process model makes another step, and then reject order is finished, it produces a token on its outgoing sequence flow, and that token ends up in the end event. The green process instance is done. Then the pink one will continue with confirm order. Once that is done, the goods are shipped and when that is done, send invoice executed, and when that is done, the pink process instance also finishes. Now notice the difference between a process, which is the thing running in real life, a process model, which is what you write down in order to communicate what the process looks like, and a process instance, which is some thing that is running through the process. So in this case, a purchase order for a particular customer. These three things are important to keep separate. So when we talk about a process instance, we mean anything running through the process model. If we look a little bit deeper into the process instance lifecycle, then the option we've seen is that we use a start event and an end event. You can use any number of start events and end events, and the process instance will start whenever a start event fires. So the environment will tell you, now we start with this start event. You cannot start from both. So if the environment decides to trigger two start events, then we get two process instances. A process instance is complete, so it ends when all of the tokens within a process have reached an end event. Then the process instance is done. This is one option, use start and end events. Another option is to not use start and end events and kind of keep them implicit. Here on the right, we see such a model. And if you don't use start and end events, then every element that does not have incoming sequence flows will get a token on start of a process instance. So in this case, this would be only A, but if you have multiple, then you get multiple tokens. In option 2, the process instance ends when all tokens have reached an element or are done after an element that has no outgoing sequence flows. So in this example, this is B. There is a small difference between the left and the right, option 1 and 2. In option 1, if you start a process instance, only one start event will be executed. On the right, with option 2, without the start events, all elements that have no incoming sequence flows will be activated. These are two ways to start a process instance and to end a process instance. And again, you cannot mix them. So if your model has a start event or an end event, then it must have both, and then the option 1 applies. If you don't use any start and any end events, then option 2 applies. So you cannot mix them in the same process. This wraps up the basics of BPMN. We've seen that you can model work using tasks, you can connect tasks using sequence flows, and you can use start and end events to denote when a process instance starts or ends. We've seen the difference between a process model, and a process instance, and I've shown a secondary option for starting and completing a process instance by not using any start or end events.